So, welcome to Mind Matter CogSci Talks, the podcast where we explore the fascinating world of cognitive science through conversations with researchers, engineers, and innovators advancing our understanding of the brain, technology, and human health. So, today I'm excited to welcome Shruti, a master's student in biomedical engineering at UC Davis and a researcher at the UC Davis Mind Institute. So, she earned her bachelor's degree in brain and behavioral science from Purdue University, along with a certificate in applications of data science, and her work brings together neuroscience, computational biology, artificial intelligence, and biomedical engineering to kind of better understand neurological disorders. So during her time at the UC Davis School of Medicine, she's worked in the Dr. Ben Shimom's lab, where she investigated electrophysiological data from high-density microelectrode arrays to kind of study how neuronal networks form and communicate in genetic neurodevelopmental disorders. And her research has explored everything from computational modeling and algorithm development to analyzing how drugs influence neural activity at the single cell level. And more recently, she's been applying AI to medicine, contributing to award-winning healthcare hackathon projects focused on accelerating cancer drug discovery through graph-based reasoning and machine learning. So thank you for so much for being here today, and it's truly a pleasure to have you on the podcast. So I guess before we dive into your research, can you tell us a little bit more about yourself? What first sparked your interest in neuroscience and biomedical engineering? And was there like a particular experience or moment that made you realize that this was the path that you wanted to pursue?
Yeah. Wow. First of all, thank you for that introduction. I was like, whoa, you did your research. But yes, thank you for having me on. Yeah, so a quick introduction about me. That was an insane introduction. But yeah, so I grew up in the Bay Area. In the heart of Silicon Valley, but I feel like I never was really exposed to engineering or tech that much growing up. Despite, yeah, my dad was an engineer, but I would see like, not to throw him under the bus or anything, but I would see him also working like late hours, and I would think
Mm,
that like this field is only for, men or like people with ties and who are, old or something. But that so originally I was very curious about just like the way the world worked, how my own brain worked, and then how like people behave and stuff. So naturally I went into like psychology and neuroscience when I was an undergrad, but when I got there and I was thinking about like where I want my future to be headed, I was exposed there in college a lot to like the computational side of things and originally I didn't really know what that meant. It was just words that I just thought were interesting. And I think one semester I was there, I took a sensations and perceptions class for my psych degree, and then I also took a neural computing in engineers class, and I would see the similarities kind of in weird ways between those two classes. Where in the neural computing class we were looking at like mathematical equations and the models behind like how neural networks are built and like how the machine how it basically how the neurons of the machine are learning and the artificial neurons. And
mm,
so when I was learning both of those side by side, I that's when I started to get into machine learning a little bit and like learning about AI. And then yeah, I like learned how to code. And then yeah, and then when I but yeah, that's a little bit about me actually. I'll save the rest for later. But yeah, so it was
yeah.
just kind of just like gradually there. But yeah.
Oh, so you didn't do like computer science or like you didn't really discover like AI or like stuff like that until college?
Yeah, yeah. Like
Mm,
I knew about it, but I didn't really know much about it, and I honestly never really thought I was like smart enough to be doing all
uh,
that. Like I was like, oh, what is this? But then over time, I realized I'm like, oh, maybe I can do it, you know?
mm. Yeah. So I guess like you also kind of talked about how you studied like psychology, and now you're pursuing a master's in biomedical engineering while also conducting like neuroscience research. So what has that transition kind of been like, and what are like the some of the biggest like lessons that you've taken?
Yeah. Yeah, th this transition was really hard actually. Not that many people do it, and it's for a reason. I think if you study like traditional engineering degree in your undergrad, it's much easier to transition to your master's
Mm,
in biomedical engineering. And I'm sure many people are, maybe someone listening is also going through that as well. Yeah, it's hard because you have to take certain prerequisites um or you have to have certain like conceptual knowledge about certain things that um you don't get if you don't have an undergrad degree. But I would say that if you want to get somewhere that's worth going, like you have to put in the work and effort to get there. And yeah, so I think it did help that I did I worked there full time before as well. But I also did get into CMU as well for a biomedical engineering program in the AI engineering department. And so I guess for that I can say try to like apply like whatever knowledge you do have to this field because biomedical engineering is very like vast and diverse. And grad schools I think want to see you like how you're connecting your own story. And so yeah, I think past the classroom itself, um the transition has been better for me because I kind of knew what I wanted through the experiences I've had. Um and yeah, so I'll have to take like differential equations and stuff next semester. But
yeah.
I'm excited for that too because like I think it's important. But yeah, I'd say that the transition it's doable. And also talking to like different counselors and academic advisors of the school you want to go to explain your situation is helpful. Yeah.
Yeah. No, because I've also been looking at like undergrad like colleges and like the course requirements for like biomedical engineering or like any engineering thing
Mm.
compared to like cognitive science or like psychology and like maybe like the College of Arts and Science is so different. And they're like, oh, well, if you do want to transfer, you have to take like three different math classes because like the math is like slower in arts and science as compared to engineering. And they're like, yeah, you also need to take like a bunch of engineering classes and like I feel like it's just so different. So I guess like that transition, I feel like if I were to do like it would have been difficult. Like,
Yeah.
yeah.
Yeah. Yeah, on that note, I would say that like yeah, do as much as you can. Online certificates help. Uh
Mm,
and yeah.
yeah.
Anyways.
So I was looking more into like what you did. So like so your research. So I saw a lot of your work focuses on like understanding how neurons kind of communicate. So I guess for listeners who don't really like they're interested in neuroscience, but they're not sure of like how it actually works, like what actually happens when the brains like communicate with each other and why studying those conversations important.
Yeah, so I would say the way that neurons communicate is basically the basis of all of like life and our interactions with each other, as well as all the neurodegenerative diseases um or behavioral patterns that we face. Basically how it works is that there's like a messenger and a receiver, and there is like neurotransmitters that send these chemicals to the receptors, and these neurotransmitters can like the level or the severity of and intensity that these chemical interactions happen between one another basically determine how the neurons are interacting with each other in a network style. So our brain is basically this big network, and how if certain neurotransmitters are turned off or certain are turned on, then that basically determines like how that interaction will go. And it's really interesting because like that's in a way how neural networks work as well with the intensity of weights. So yeah, I would say these interactions basically shape our network, and then that leads to different deficiencies in certain areas of the brain um, or lead to like different nerve connections that are different between the gut and the brain and stuff like that. So, yeah.
That's really cool. So when I was looking more into your research in like the Bench-Alone lab, I saw that your research also uses like high density microelectrode arrays to kind of record the activity of neurons. So what kind of makes this technology like so unique and like exciting in a way, and what kind of questions can it answer that others can't?
Yeah, so I would say that there's different like technology that are used obviously for neuroscience. One example is like patch clamping, which takes like single cell recording data, but it doesn't take the network data of a whole neuronal network. And then the other end of it is like EEGs or any sort of neural interface that can take your brain activity, but it doesn't have any spatial or temporal like isolation of where the activity is happening. So it's like very broad. So I think MEAs, how it basically works is you plate these like cell cultures, so these different neurons, um, and there's like organoids and like primary neuronal cells. Basically, there's like these hundreds of thousands of cells on the plate, and you're able to see not only the network activity of all of them, if you manipulate them, like if you add different drugs to them, or if you look at their longitudinal study, you can also see them in like single cell levels. So
Mm,
the resolution is really high in the sense where you can see actual like axon morphology or the whole network. So I think that this technology is like a good mix of being able to see high resolution data from a single cell level and also in a network level, which helps us get more insights about how it all comes together.
yeah, that sounds really complicated of like how your brain kind of works, doing like high resolution and also like a network level. So I guess, yeah, that just kind of shows how complex the brain is. So I guess like has studying the brain made you think differently about yourself or like about the way people learn, make decisions, or interact with one another?
Yeah, I think working in this lab has definitely like shown how how close we are to getting the answers that we want for different different diseases and stuff like that. But it's really interesting to see like the chemical interactions or the and chemical interactions and electrical activity like happen in real time. Like you're able to see how adding more gabazine can like increase activity or amplitude of our our network. So I think that's been really interesting. I also think just in general, like seeing an morphology of an axon is really cool as well with the technology. Um, and being like, this is actually happening in our brain right now. Um, Obviously we use mouse models, so it's different, but the overarching theme is the same. And I think studying neuroscience has helped me in the sense of like being kinder to myself because you realize there's a lot of stuff you can't control. Like things are just be happening up there sometimes. And so yeah, definitely being kinder to yourself and also understanding that you can be whoever you want to be because you can train your brain to be what it wants to be. So yeah.
So I guess you kind of mentioned how like you guys use your technology to see how I'm assuming drugs, or you mentioned like something out. It seemed really complicated, so I'm assuming it's a drug and it can kind of change like how neurons behave in real time. So was there a moment in the lab that genuinely like surprised you or completely changed how you kind of think of your own brain? I know you mentioned like there's a lot of things out of your control and it just happens, but is there anything
Yeah.
else?
Okay, okay, I might have answered both questions.
Oh,
That was
okay.
kind of that last part was kind of the answer to that question.
Oh,
Yeah.
they learn to
But
like be nicer to yourself. Well, yeah, that actually, yeah, that's really interesting.
yeah. Yeah.
So I guess like,
Um,
sorry. Oh, as AI gets more like AI is so popular nowadays. I feel like everyone around us is talking about like, oh, you either like make an AI or use AI, or you just have to like learn AI or something. So I guess like one thing that stood out to me about like your research is using algorithms to kind of analyze enormous amounts of neuro data. So I guess in your opinion, like what point does artificial intelligence kind of become really essential in neuroscience research, especially like nowadays, since I know AI, like with such big like data sets, like you guys probably don't do everything manually, right? So what are your thoughts on that?
Yeah. Um, I think I think AI is helpful for researchers to like to help them with their coding. Obviously, that like it helps them like reduce the time from 3 weeks to 1 day to do like a task with Python or something. But I would say on a different level, you could use AI to build these foundation models because with any large scale data, you can basically feed it into this foundation model. And what that does is creates a representation of whatever you're doing. And then from there, you can create these simulations. I don't know if that, okay, so yeah, so simulations are basically like, let's say you don't have to be in the lab itself. You can just basically run the same experiment on this simulation, which is just um like a digital version of whatever you're doing, and then you can predict the outcome of there. Like for example, like the drug example, like instead of having to spend 2 weeks culturing these cells and then like running an experiment, if you create like a this model online, then using AI, then you can like basically predict what happens. Just using the past data that's already been there. But I think that's very far from reaching a level where it can be like used without any wet lab work. Um, and I think it can also be used to like, yeah, like predict different neuron cell subtype classifications or like it can be used for just understanding like different patterns in the noisy signals that we get from our raw data that maybe humans can't see as much. Um, and yeah, but I think it's very far from there right now. I think it's not super essential as of now, but it might be. I don't really know. But it can be useful. And also another thing is like AI is like the research of AI itself of like understanding the weights that go on or understanding how it thinks might be able to help us re reverse engineer how we actually think and like the math behind like how we work might become better once we understand how this black box behind AI works.
Yeah, I heard that you mentioned like simulations. I mean, I feel like in my opinion, like it's so hard to, I guess, model and train that, or especially like, or if you, unless like you might use AI to create simulations and like model and train it, but how do you like do that without giving it like too much data? Because I'm just thinking about like the ethical concerns over like giving like I don't know, like large language models so much like data.
Yeah. No, that's a really good point. And I don't really know too much about it. That wasn't one of the things I worked on. That was actually a project of someone in my lab's like PhD. Like that was his whole PhD project.
Oh,
Is figuring out how to do that. So he's using all these different models and he's like a very computationally heavy person. But you're right. You're right. There's a lot of ethical considerations when it comes to that, which is why it's like very far and it's hard to trust as well. So I think that in neuroscience, AI can be useful for, yeah, just like understanding and detecting like noisy patterns and yeah, but I guess, yeah, not so much simulations yet,
mm,
but we'll see. But
yeah.
I know there's some like companies out there or startups that are working with like trying to create digital brain maps and stuff of of um of our consciousness, stuff like that. So,
That's really interesting. Um, I guess like a little bit more on the AI, like I guess outside of neuroscience, do you think it's like okay for students, like if they're studying like or whatever they're majoring in, like do you think it's okay and to what extent should they be using like AI too?
Yeah. That's a really good question because I think it's like taken over too much for to the point where it's like being force fed down our throats, and I can't even imagine how it is in college right now. It must be terrible because everyone is like talking about it in this like propaganda sort of way, and it is overhyped in some way. It is true in some sense, like it can be super helpful. But I think that um, there's a lot of noise out there. I would say try to ignore the noise as much as possible, and really learn how to like think deeply about something. Like I know even I'm struggling. I'm still figuring this out too, but like understanding to not be like, oh, this, to go to this, go to this. Okay, this looks all right. This looks all right. And then like move on. Like sometimes it's good to like look at something and be like, wait, I think that this could be done a different way. Or like, oh, why is this happening this way? And just kind of being curious and asking yourself these questions is so important. And I think that AI um can be useful, but at the same time, it's not that useful. Like if you're trying to learn something.
Mm,
Um, Like I tried using ChatGPT the other day to like learn like I got this 3D printer from the hackathon and I was trying to learn how to like use it and build this project. But it would just spit out like the same things over and over again that so I was like, okay, I'm just gonna use a Google website that was created like 10 years ago for this. And so yeah, so consciously making those efforts not to take away the thinking aspect of it, even though it might be hard, and reducing the noise. I
yeah.
don't know if that answers
I
your question.
I saw that there was like a Brown study where they studied like there was like an exam that they could like bring home. So they took it at home and like everyone had like 90 somethings like A's and they're like, oh, we've never seen this in the past because it's not a class that like kids should be passing, but that's also kind of concerning. But aside from that, they like
Yeah.
made them take it again like a week later when they came back onto campus and like almost everyone like failed the test.
Oh my
So I
God.
don't know how much learning like I don't know how much they got
Yeah.
in, but yeah. So I
It's a
guess like
stressful time.
sorry.
No, I just said it's a stressful time.
Yeah.
Um, yeah.
Yeah. So I guess finally we have like a lot of high school students and college students who might be like undergrads who are maybe like interested in neuroscience, biomedical engineering, AI, and like computational biology. So do you have any advice for them of like what are some like technical skills they should have or some like soft skills that they should have?
Mm. Um, yeah. So I think that knowing how to vouch for yourself is very important. Like speaking up for yourself or like that
Mhm,
communication is super important. I would say I wouldn't say okay, so I know so many people are like, oh, learn Python or like learn
mhm,
this. I think it's really hard to like just go down that rabbit hole of it's hard to learn it by going down the rabbit hole of just like watching YouTube videos or like trying to do like a course or something. I think like it would be helpful to like have one project in mind that you want to complete. It could also be from YouTube, like a YouTube project as well, but um like yeah, try to do it from start to finish and you could use AI too, but like try to just do a like a project you're interested in rather than focusing on like learning like I guess learning the skills is important too, but and I'd say also don't give up, keep following your dreams. And this is a very interesting space right now, especially biomedical engineering, because there's not only like software components, there's also like hardware components and neuroengineering and BCIs, and it's all very exciting. But in undergrad, I would say don't stray away from like learning the fundamentals. Take your classes seriously if you want to go into the engineering, do it for your undergrad. Switch into that major or computer science or something around that if you want to do that. But um, I think that will help you a lot in the long run. And um, and keep your whimsy. And we're all just figuring it out, I guess. And um, and try to gain qualities or characteristics like discipline and like try to do your homework assignments without AI. Um,
Feel like nowadays, like, or like
I
I
don't
know
even
at
want
my
to say
school,
that
like,
because I'm like I can't even
yeah,
imagine.
like every time I go, like we have
Yeah.
like a library race. So like every time we go to I go to the downstairs of the library, I swear like I see Claude on like everyone's screen. I mean, it's definitely concerning, but I mean, I think everyone's passing their classes for now, so I guess it's working
Okay,
to an
but
extent.
I see. In your perspective, how is it? I don't know if the timing for the recording is
Oh,
gonna
it's
like
okay. It's okay.
okay.
Well,
Okay,
I mean, I
cool.
kind of studied like because I'm in the burner lab and like one of my individual projects was like looking at how AI affects like education and like cognitive offloading and what it does. And apparently it's not
That's
good
very
for you or your memory retention. So, or for your cognitive effort. So what I learned is like you need to struggle a little. So then you can
interesting.
like actually like learn it. But like the problem is nowadays, like everyone, like every time they run into a problem, like I feel like even for me, like sometimes when I'm doing like physics and I like run into a problem and I'm like, oh, I have no clue how to do this. Like I just
Mm,
immediately like put it into AI and I'm like, oh, please help me solve this. But like I feel like for me, I mostly use it
yeah.
for like study guides or especially like for history. I'm not good at history, but like timelines or like specific details. Like I think the way you use it is important, but like it definitely is easy compared to like doing stuff by yourself. That's kind of my perspective. Yeah.
Yeah. No, yeah, I agree with that perspective. I think one thing you could do is like I think it's fine to use it, especially because I feel like everyone in their mind would be like, yeah, this is a time efficient way of doing it. I could just look it up on ChatGPT or like on somewhere and
Yeah,
I can just
yeah.
get the answer. I think that's fine. But like I think one thing is if you teach it, you could you that proves that you know it. So like
Mm,
if there's a concept that like you have for a test or something, then like if you can like recall it actively and then like explain it on a whiteboard or something, I think that's a good sign that you know because that usually also
mm,
shows like where you have gaps in your knowledge and stuff. Um so yeah, but that's a really interesting perspective. Yeah, that's cool.
yeah. I know that like AI, like, well, actually, I don't even know. Like, it's not good, but I feel like I know also like does or I don't know about like other large language models, but I know ChatGPT specifically likes to hallucinate things. Like I remember like putting in like my US history notes and it just like out of nowhere it starts like telling me random dates and I have to like Google it to make sure and it's like not even right. I'm like, oh, ChatGPT, like you're wrong. And they're like, oh wait, sorry, like this is what I meant. I was like, okay. But
That's when you
yeah,
know it's so cooked. Like,
yeah.
yeah, when
That's
you're
when you
telling
know it's like
it
your
that,
time to
yeah.
stop. Yeah. So I guess that kind of brings us to the end of today's episode of Mind Matter CogSci Talks. So thank you so much for joining me today and sharing your journey, your research, and your insights for advancing neuroscience and biomedical engineering. It was fascinating to hear about your experiences in the lab and in undergrad and your perspective on, I guess, the exciting future of AI in healthcare and your advice on AI. And thank you so much for taking the time to be here today. And I guess thank you to everyone for listening. And I hope you enjoyed this conversation and came away with a deeper appreciation for how neuroscience, engineering, artificial intelligence, I guess, like, and computer science are coming together to kind of transform like medicine and our understanding of the brain. So I guess until next time, stay curious, keep asking questions, and thanks for listening. So thank you.
You